Good day everyone, I am Juliet and Arsenio and today I will be discussing selected items from our problem set. It is about multiple integration and differential equation. Let's start. Evaluate the iterated integral. Next is obtain the general solution of the following differential equations. Okay, let's start with the double integral of x y squared dy dx from 0 to 2x and 1 to 2. The first thing we need to do is to integrate first the inner integral, which is the integral of xy squared dy from 0 to 2x. The integral of y squared dy is y cubed all over 3. Now we have the integral of 1 to 2x times y cubed all over 3 from 0 to 2x dx. Next is we need to substitute 0 and 2x to our y. By applying the rule of exponent, we have 8x cubed all over 3. Next is multiply x to our 8x cubed all over 3. And now we can integrate the 8x raised to 4 all over 3 dx from 1 to 2 by applying the power rule. Next is substitute 1 and 2 to our x. 2 raised to 5 is equals to 32. Copy the denominator, which is 5, minus 1 raised to 5 is equals to 1. Copy the denominator, 5. Using your calculator, calculate this one. We have 248 all over 15. Therefore, the double integral of xy squared dy dx from 0 to 2x and 1 to 2 is equal to 248 over 15. Next problem is double integral of sine x over y dx dy from 0 to y squared and pi halves to pi. Same with the problem 1. We need to integrate first the inner, which is the integral of sine x all over y dx from 0 to y squared. Next, we need to apply the u substitution. We let u be equal to x all over y and du is equals to 1 over y dx and multiply both sides by y. We have y du is equals to dx, and after that substitute the value of u and at the same time the y du in the given problem. The integral of sine u y du from 0 to y squared. And for us not to be confused, we let y be a constant, so we can rewrite this problem into this form. Y, the integral of sine u du from 0 to y squared. And the integral of sine u du is negative cosine u, which is the u is x over y. And then substitute 0 and y squared into our x. Now we have negative y cosine y squared over y minus negative y cosine 0 over y. Negative y cosine y squared all over y is equals to negative y cosine y, and negative y cosine 0 is equal to negative y. By applying the rule of integers, negative times negative is equals to positive. So we have the integral of negative y cosine y plus y. dy from pi halves to pi. Next is integrate them differently. So here we need to apply the integration by parts. For negative, the integral of y cosine y dy from pi halves to pi, and power rule for the integration of y dy from pi halves to pi. After integrating, substitute pi halves and pi to our y. And also, don't forget to simplify your answer. Now we have 1 plus pi squared over pi plus pi halves minus pi squared over 8. Pi squared over 2 minus pi squared over 8 is equal to 3 pi squared over 8. Therefore, our final answer is 1 is equal to 1 plus pi squared plus 3 pi squared all over 8. And now, let's proceed to another item. This item is an example of triple integral. So, same with the number 1 and number 2, we need to integrate first the inner integral. So, here, we need to let x be a constant. So, we can rewrite this problem in this form. X, the integral of dz from 2y to 1 plus y squared. The integral of dz is simply z. And after that is, we need to substitute 2y and 1 plus y squared to our z. Now we have 1 plus y squared minus 2y. And we need to distribute rather the x in our 1 plus y squared minus 2y. And after that, integrate them separately. Now we have xy plus xy cubed all over 3 minus xy squared. Since we already done in integrating, we are going to substitute 0 and 1 minus x to our y. And then expand and at the same time simplify. So here, we also need to find the LCD. So as you can see, our LCD is 3. Positive 3x cubed minus 3x cubed is equals to 0, and negative 3x squared plus 3x squared is also 0. Therefore, we only have negative x raised to 4 plus x all over 3. And also, we are going to integrate them. So for us to not to be confused again, you are um, you can rewrite this problem in this form. And then let's integrate it together by by using the power rule. Since we already done, we need to substitute 0 and 1 to our x. And using our calculator together, let's calculate this one. This problem is equal to 1 over 10. Therefore, we can conclude that this triple integral is equal to 1 over 10. Now let's proceed to another item. This item is for finding the general solution by applying the differential equation. Let's start with this problem. T times the quantity of s squared plus t squared ds minus s times the quantity of s squared minus t squared dt is equals to 0. This problem is an example of homogeneous differential equation. Why? It's simply because each term has the same degree. So this problem has uh, a degree of 3. So we are going to apply the homogeneous differential equation. So we let t be equal to Vs and dt, or the derivative of t, is equals to V ds plus s dv. So here we are going to substitute t and dt to our given problem and expand and at the same time simplify. Now we have 2v cubed s cubed ds minus s raised to 4 dv plus s raised to 4 v squared dv is equals to 0. Next is we are going to add both sides by negative 2v cube s cube, and at the same time again we are going to multiply both sides by 1 over s raised to 4 and negative 2v cube. And then we have negative 1 plus v squared all over negative 2v cube dv is equals to s cube all over s raised to 4 ds. And also, we are going to integrate them separately. Take note that we can rewrite negative 1 plus v squared all over negative 2 v cubed dv in this form. And the integral of 1 over s ds is simply ln s. Now we have negative 1 over 4v squared minus 1 half L and v is equals to L and S plus C. By applying the rule of natural logarithm or logarithmic, we are going to multiply both sides by e. Now we have e raised to negative 1 over 4v squared minus v raised to 1 half is equals to s plus c, or e raised to negative 1 over 4v squared minus v 1 half minus s is equals to c. By applying the homogeneous dE, the general solution of the given problem is equal to e raised to negative 1 over 4v squared minus v 1 half minus s is equal to c. For the last item, we are going to use or apply the linear equation of order 1. So we are going to use this formula. So we should be mindful for this, for us not to make a mistake. Take note that it is a linear in y if dy all over dx plus p of x y is equal to q of x. And the formula to be used is y e raised to the integral of p of x dx is equal to the integral of q of x e raised to the integral of p of x dx. Next is it is a linear in x if dx all over dy plus p of y x is equal to q of y. And the formula to be used is x e raised to the integral of p of y dy is equal to the integral of q of y e raised to the integral of p of y dy dy. Okay, let's have y prime is equals to x minus 2y cotangent to x. So here we are going to apply the linear equation of one order. First is we need to rewrite our given problem into this form. dy over dx plus 2y cotangent 2x is equal to x. This problem is a linear in y. So we can use the formula. We have y e raised to the integral of 2 cotangent 2x dx is equal to the integral of x e raised to the integral of 2 cotangent 2x dx. So, um, by the way, our integrating factor in this problem is e raised to the integral of 2 cotangent 2x dx. And take note that the cotangent 2x is equal to cosine 2x over sine 2x. So here we are going to apply the u substitution. After applying the u substitution, we have y e raised to the integral of dv over v is equal to the integral of x e raised to the integral of dv over v dx. So take note that the integral of dv over v is equal to ln. So ln sine u, ru is 2x. So now we have y e raised to ln sine 2x is equal to the integral of x e raised to the integral of ln sine 2x dx. So by applying the rule of natural logarithm, we have y sine 2x is equal to the integral of x sine 2x dx. So here we are going to apply the integration by parts. And use substitution for the integral of cosine 2x dx. We have negative 1 half x cosine 2x plus sine 2x over 4. So here we are just rewrite the given problem. So y sine 2x is equal to the integral of x sine 2x dx. So we already done integrating x sine 2x dx, right? So this is equal to negative 1 half x cosine 2x plus sine 2x over 4. Next is we're going to divide both sides by sine 2x. So we have y is equals to negative 1 half x cotangent 2x plus 1/4 plus c over sine 2x. Therefore, by applying the linear equation of order 1, the general solution of the given problem, y prime is equals to x minus 2y cotangent 2x is y is equals to 1 half x cotangent 2x plus 1/4 plus c over sine 2x. That's all. Thank you.